A very warmest welcome to everyone in my new video. Today we are going to talking about what are fats and what are lipids. What are the basic differences between them? What are the sources of fat and lipids? What are the types of fat and lipids? Let's talking about everything with the deep knowledge. Now, what are lipids? Triglycerides makes up the largest class of lipids. They include nearly 95% of all the fats and oils that we have and store in our bodies. What are phospholipids? A combination of fat and a mineral phosphorus having a molecular structure that allow them to dissolve in either fat or water. They are found naturally in some foods such as egg, soybean, peanuts, and are widely used in the food industry. Lecithin and cephalin are common names. What are esterols? Esterols are found in both plant and animal food. Cholesterol found in animal food is well known. The well known term fat, okay? Fat is not scientifically accurate. Fat are actually part of larger grouping of substances called lipids. So it is clear that fat are actually a part of larger grouping of substance called lipids, okay? Lipids are a family of chemical compounds. They are a main component of every living cell. There are three categories of lipids. Now, sources of lipids. Sources of animal fat include blubber from sea mammals, including whales, cod liver oil from cod fish, lard from pork fat that is processed by cooking method, rendering, tallow rendered from hard beef or mutton fat called suet. Escmalds or escmals is a rendered pea, the brown fatty residue left in the pan after frying bacon and melted pork fat that is a whitish color. Goose fat used for frying or as a spread on bread, especially in German, Polish or Jewish cuisine. Chicken fat and fat in egg yolk. Okay. Cream butter, whipped milk fat or cream. Ghee, pronounced ghee, butter with water and milk solids removed by clarifying, that is used in South Asian, Indian, Middle Eastern cuisine. Now, coming to the next point, some of the many different kind of edible vegetable fat includes olive oil, palm oil, soybean oil, canola oil, pumpkin seed oil, corn oil, sunflower oil, etc. Okay. Now, function of triglycerides in the body. What is the function of triglycerides? It's mean fat in the body. Fat is a poor conductor of heat. So a layer of stored subcutaneous fat just under the skin and is adipose tissue provides the body with warmth. Fat is easily metabolized into energy, supplying almost twice as much energy per gram than carbohydrate. Fat help keep the skin supple and hair glossy and healthy. Fat cushion organ, protecting them from impact. Too much fat around organs, however, can hinder their functioning. Fat add satiety to the diet. It provides a sense of fullness or satisfaction. Fat transport vitamin A, D, E, and K through the bloodstream. Now, function of phospholipids and esterols in the body. Okay, phospholipids and esterol are the building block of our cell membrane and also participate in the transfer of genetic information across the membrane. Phospholipids and esterol along with sun exposure on the skin are used by body to make vitamin D. That's why phospholipids and esterol are very important. Structure of triglycerides. Okay, fatty acid are the building block of all fats. Okay, the name triglyceride is a combination of tri for the three fatty acid components and glyceride, a glycerol alcohol compound. Not all fatty acid are the same. They may consist of short two carbon chain and or an 18 carbon chain with oxygen and hydrogen. The body can make triglyceride in the liver or get them from food source. Saturated and unsaturated fat. Saturated fatty acids with names like stearic, butyric, palmitic acid hold all the hydrogen atom. Their molecular structure can hold. They are hydrogenated. Unsaturated fatty acid are missing one or more hydrogen atom and two carbon atom form a double bond with each other instead. All other atoms must have four bonds. The double bonds create a kink in the chain. As you saw image in this PPT presentation, most animal fat are saturated since all hydrogen atoms are present. They are denser than oils and are usually in a solid phase at room temperature. Most plant oils, excluding coconut and palm kernel oil, are unsaturated, usually in a liquid phase at room temperature. Monounsaturated and polyunsaturated fats. Okay, now the first figure, butyric acid, saturated fatty acid. Okay, the carboxyl group and a carbon chain, all hydrogen present, is equal to saturated fat. Now the second image is oleic acid, monounsaturated fatty acid, carboxyl group and one hydrogen missing on a carbon chain, monounsaturated fats. Now the third figure is linoleic acid, polyunsaturated fatty acid, carboxyl group and multiple hydrogen atom missing on the carbon chain, that is called polyunsaturated fats. Monounsaturated fat is found in high content in olive, peanut and canola oils. Polyunsaturated fat food source include soybean, sunflower, fish and corn oils. Lowering the intake of saturated fats in the diet using mono and polyunsaturated fats instead lowers the risk of heart disease. Function of fat in cooking. Fat coats the flour particle in baked good such as pie crust. This creates tenderness, a flaky, delicate, lighter texture. Fat adds flavor. Each type of fat or oil has its own distinctive flavor. The small flake of intramuscular fat in beef called marbling affect flavor and juiciness and may contribute to tenderness. Creaming, beating fats prior to baking adds aeration, dispersing gas or air bubbles in the batter or dough, causing a batter to flow more easily and causing the food to rise when baked. Function of fats in cooking. An emulsion is a dispersion of an insoluble liquid in another liquid, such as oil in water. Okay, it is basically an example. Okay, so there is a image, oil and water emulsion. Okay, fat played two roles in creating emulsion, as an ingredient in making the emulsion or as a stabilizer after one is formed. So there is two use. One first one is emulsion and second one is a stabilizer. Now, melting and solidification point of fat. The molecular structure and saturation of fat affect their melting points. Most fats having a melting range rather than a melting point, depending on which fatty acid are present. Generally, the more carbon atoms a fat has, the higher the melting point. Okay, more carbon atoms, higher melting point. The more hydrogen atoms present, the higher the melting points. Okay, margarine, a monounsaturated fat, melts at 25 degrees centigrade. Butter, saturated fat, melts at 33 degrees centigrade. Crisco, a hydrogenated fat, melts at 47 degrees centigrade. The solidification point, the temperature at which a melted fat regain its original original firmness is lower than its original melting range. Fats created with two or three very similar fatty acids will re-solidify with a grainy texture. Oxidation and rancidity. Okay, the most common defect if any food material having some fat. Okay, as the surface of food containing fatty acids react with oxygen, a chemical chain reaction occurs that changes the flavor and eventually causes the food to spoil. This is called oxidation. Unsaturated fat are more prone to oxidation than saturated fat. Heat and light speed the rate of oxidation. Cooling, even freezing, slows it but does not stop it. Water inhibits oxidation because the water interferes with contact between air and fatty acid. Rancid is a term that describes the unpleasant flavor that develops as fat oxidizes. Cracking and smoke point. Cracking is a term that refers to the deterioration of fat resembling oxidation. It is caused by repeated exposure to intense heat plus the addition of fat liquids and other substances on or in food that is being fried. Cracking can discolor the oil and produce off flavor and odors. A smoke point is a temperature that a fat begins to break down, release smoke and burns. When oil is hot enough for simmering but has not yet reached its smoke point, it simmers and separates into tines. Oils with higher smoke points are best for frying. Sunflower oil minus 440 Fahrenheit, canola oil 400 Fahrenheit, butter 350 Fahrenheit, and extra virgin olive oil 320 Fahrenheit. Hydrogenated oils. It is possible to take bottles of oil which is polyunsaturated and in liquid form at room temperature and turn into a solid fat. You would you would do that by the process called hydrogenation and involves replacing the double bond on the carbon molecules of polyunsaturated fat with single bond and extra hydrogen molecules. This is accomplished with heat, pressurized hydrogen gas using nickel as a catalyst. Hydrogenation increase stability and shelf life. Hydrogenated fat do not soak into foods or ooze out before the food is eaten. Like animal fats, they usually have a fuller flavor. If the manufacturer replaces all the double bond with single bonds and hydrogen, it is called fully hydrogenated and the product is very hard, too hard to use for cooking. If only some of the double bond are replaced, it is it is called partially hydrogenated and the product is semi-solid like vegetable shortening and margarine. Margarine is a hydrogenated oil. It was originally called oleomargarine. Okay. Oleomargarine. What are trans fat? The most common thing that will be available on every food wrapper on the behind side on the nutritional bar. Okay, now talking about trans fat, also known as trans fatty acid, is a type of fat created through the process of hydrogenation. When a mono or polyunsaturated oil is hydrogenated, it is not possible to control where the hydrogen atom are added to the structure. If both hydrogen atoms are added to the same side of the structure, it is called a cis fat. Cis means on the same side. Fat exists naturally, and because the hydrogen atoms are crowded on one side of the molecules, they bend, allow other chemicals and digestive enzymes to bind to them. If, however, one hydrogen atom adds to one side of the structure and the other atom to the other side, it creates trans fat. Trans fat do not usually exist naturally because the structure is uncrowded. They do not bend, and so other molecules and enzymes find it more difficult to bind to them. They do solidify at room temperature. Cholesterol is an animal fat, a sterol or fatty acids made from glucose or saturated fatty acid. It is yellow and waxy. The full amount needed for the production of vitamin D and the creation of cell membrane is made in the liver. No dietary intake of cholesterol is necessary. All cholesterol from the liver or the diet is transported through the bloodstream out to body tissues in molecules called lipoprotein. Okay, they are large and complex and made from a large quantity of the lipids and a smaller amount of protein, that is called lipoprotein. Since it is not dense molecule, it is called a low density lipoprotein, LDL. Returning from the tissue back to the liver, the amount of protein exceeds the amount of lipid, so the molecules are now denser and are called high density lipoprotein, HDL. They can actually pick up excess LDL, low density lipoprotein, cholesterol still in the bloodstream and return it to the liver. This is good. Heart disease and lipids. Too much hydrogenated or partially hydrogenated fat, trans fat, saturated fat, or cholesterol has the same effect in the body. They contribute to heart disease. As these fat are dispersed in the bloodstream, they are sticky and cling to the interior walls of the arteries. As this buildup occurs, plaque is manufactured. This is a mixture of lipid, calcium, and smooth muscle cells that can contribute to the hardening of the arteries or ath- atherosclerosis. The accumulation of fat and plaque on the interior walls of artery reduce blood flow and raise the risk of heart attack and strokes. Omega-3 fatty acids. Omega-3 fatty acids found in fish oil and some nut oil is a group of polyunsaturated fat. Studies shows that these oils make it more difficult for plaque to form in the arteries, thus lowering blood pressure and the risk of heart disease. Although research is not conclusive, intake of omega-3 fatty acids has also been linked to relief from the inflammation of arthritis and gastrointestinal disorder and omega-3 fatty acids. Okay. Excellent source of omega-3 fatty acids are the fatty fish such as salmon, albacore tuna, halibut, mackerel, sardines, herring, and lake trout. Cod liver oil and some nut oil such as that from pecans, hazelnut, walnut. Linoleic acid, linoleic is the only essential omega-3 fatty acid. Okay. Omega-6 fatty acid. Linoleic acid is the only essential omega-6 fatty acid. The body can make all other omega-3 and omega-6 fatty acids, so they are not required in diet. Linoleic acid is necessary for normal growth and development and is found in vegetable, grains, nuts, seeds, canola, flaxseed, olive, corn oil, garlic, soybean. A healthy diet should contain 1 omega-3 fatty acids for every 4 omega. A healthy diet should contain 1 omega-3 fatty acid and every 4 omega-6 fatty acid. A ratio of 1:4. The American diet tend to be unbalanced with the ratio often being 1:30. Recommended daily allowance RDA. Okay. No recommended daily allowance has been set, but a maximum of 30% of your daily calorie intake should come from fats. Take the calorie you eat per day and multiply by 25%, then divide by 9 to get your fat gram allowance. For instance, if you eat 1500 calorie per day, multiply by 25% to get 375 fat calorie, then divide by 9 to get 42 fat grams. Spreadable fat options. For convenience, consumers still demand a butter or margarine product that is spreadable at refrigerator temperature but without the health risk of hydrogenation. This has been accomplished by blending the margarine or butter with water or oil as an additive. These products may not be suitable for baking. Some spreadable margarine are over 50% water. Some spreadable butter are blended with canola, soya, or corn oil. Low fat and fat replacer options. Fat replacers can help reduce a food's fat and calorie levels while maintaining some of the desirable qualities fat brings a food, such as mouthfeel, texture, and flavor. Names of common fat replacers include cellulose gel, dextrins, modified food starch, guar gum, and gum arabic. Example of food additives that are used as fat replacers are polydextrose, carrageenan, and polyester. Unfortunately, some people see the low fat label as a license to overeat. It is important to remember that light or fat free doesn't mean calorie free, and in fact, some low fat and fat free foods are high in calorie. Product labeled reduced fat may still be high in fat, just lower than the original product. Some fat replacers may be calorie free because the fat in the product is indigestible. FDA definition. Okay. Synonym for low little few for calorie contain a small amount of low source of 3 gram fat and or 40 calorie or less per reference amount. Okay. Now thank you very much to watching my video. So if you liked it, just share with your friends to know more about what are fats, what are lipids, what are the types. Thank you.